So today we're learning about cones, and cones have the same formulas as pyramids because of the fact that they're very similar to pyramids, right? They have one base, not two. They have a vertex, but what they also have in common with pyramids is that there's a right triangle here, and you're going to end up doing a lot of Pythagorean theorem. So it says label the radius. The radius, of course, oh boy, that is way too thick. The radius, of course, is the radius of the circle. The height is the height of the cone, and we usually use capital H for that. If you use lowercase h, it's not a big deal, but in the formula, the capital H is height of the three-dimensional figure. And then slant height, I usually write in cursive or italics, but just know that L on your formula sheet is written, not in cursive. So you got to know that that's an L and not a 1. And like I said, sometimes if you go online, they use S for slant height. Slant height goes down the side. Height goes from top to bottom. If you had a cone, that's solid, and you had a measuring tape, it's hard to measure through the inside of something, but along the outside is easy. And the slant heights, no matter where you measure, would all be the same in a cone if you're going the shortest path from the top to the edge of the cone. It says to label the axis. This line, that's the height, is the axis. So you can write that down. We're hardly going to talk about it. The only time that it would really matter is if this was not a right cone. If this vertex was not directly above the center, if it was off center, then the axis would be at an angle and be different than the height. But we're only doing right cones, so that shouldn't be an issue. Okay, I'll write the formulas down for you. And I know you have them on your formula sheet, but it helps to see them. So again, that's the same as the pyramid formula for lateral area. Lateral area does not include this circle. And that P is perimeter of the base, which for a circle is circumference. For surface area, it's 1/2 PL plus B. And then for volume, it's 1/3 capital B times capital H. And I don't think we need to keep writing this down, but P is perimeter of the base, capital B is area of the base. If you feel like writing those down, you can, but those haven't changed. Okay, let's do a problem. So it says find the exact lateral area, surface area, and volume of the cone below. I like to write the P, the B, the L, and the H down near the figure so that we can get that all organized. And, sometimes you're given some of the pieces and not others. So in this problem, that 8 is the radius. And we're certainly going to use that 8, but it doesn't go into the formulas per se, right? There's no R in the formulas, but we're certainly going to use that R. This is the H. So you can write down that's 15. And, like I said, you can do a lot of Pythagorean theorem because this is always a right triangle. Now it helps to know the Pythagorean triples because you would just automatically know that side. Does anybody know what that other side is that goes to 8 and 15? No one remembers. Well, let's write down the Pythagorean triples. So I'll write them at the top of the paper. So 3, 4, 5 is usually the one that people have the easiest time remembering. There's 5, 12, 13, 7, 24, 25. So that's, that's not this one. I think we used 7, 24, 25 in the last notes. 8, 15, 17. That's this one. This is 17. Of course, if you do Pythagorean theorem, 8 squared plus 15 squared equals c squared, you would end up with 17. And there's 9, 40, 41. And there's also multiples of these. In other words, if you take 3 of these numbers and multiply them by a number, like if you multiply this one by 2, you get 6, 8, 10. 6, 8, 10 is a very popular one. But you can multiply any one of these by any number, and that would be a triple. But since we just use a triple directly from this list, this is the 8, 15, 17 version. And so if you memorize those numbers, you just know that's 17. Okay. It's not necessary. It's just helpful. Okay, so that slant height is 17. Use red. That is that lowercase l. So I have height, slant height, radius. P is perimeter of the base. The perimeter of the base is the distance around the base, which in this case is a circle, and the distance around the base is the same as the circumference. So I know we use the letter P, but you would need to know that that P is just referring to the circumference. It's around the circle, that's what circumference is. And so I'm going to do the circumference formula, 2 pi r, which ends up being 16 pi, which is where I'm getting that capital P from. Up here, you can make a note that for that P, you're always doing 2 pi r times L. So this P is always 2 pi r. So somebody could memorize it this way, and in fact, that 1/2 and that 2 would just be 1, and it ends up being just pi RL. But that's not the formula on your sheet, so we're not memorizing it that way. Okay, and then B is area of the base. The area formula for a circle is pi r squared. And so in this case, I'm doing pi times 8 squared. I'll just write 64 squared, or 64 pi, which is 64 pi. Now that 64 pi is in square inches. So that perimeter is in inches, lateral area is in inches, height is in inches, the capital B is in square inches. So that surface area, that B is always found the same way, pi r squared. Okay, so this B is always pi r squared. So what I'm writing in green here is just like an alternate way of memorizing it, or at least understanding that it's not a variety of things you do for the P and the B. The P is always 2 pi r, and the B is always pi r squared. And then same thing with the volume. The B is always pi r squared. And so, these P's and these B's are always done with those same formulas. Okay, so for the lateral area, I am just doing 1/2. That's part of the formula. P, which we wrote down as 16 pi, times slant height, 17. And then, the answers we're looking for are exact. So when I type this into my calculator, I'm just putting all the numbers in except for pi, and I get 136 pi. I'm going to write it underneath because there's not a lot of room. So that lateral area is 136 pi. If you write 136, it's not just that you didn't put the pi and you mislabeled it. 136 pi is a totally different number. 136 pi would be, 427 point something. And that lateral area, what it means is that if you flattened out the cone, it's all of this area on the outside of the cone. Now, if you unroll a cone, let me explain what it looks like. And you can make a cone at home by doing this. If you take a circle and you cut out a piece like you're making a Pac-Man symbol, that would be what a cone looks like. I don't know if I could do a great job of drawing this, but this is what a cone looks like unfolded. And if you were to join these two sides, in other words, you're going to take this and this, which are the slant height, by the way, and match them up and bring them together, then that would point upwards and you would have the cone. And then this, which would now complete the circle, would be the perimeter of the base or the circumference. So that's what a cone looks like unfolded. So we're finding for that lateral area, this shaded area in here that, you know, is again flattened, that doesn't include the bottom. Okay, so I'm going to get rid of that because of the fact that somebody copying the notes would have no idea what that is necessarily. Okay, so then for the surface area, again, this is the same. So I could just write 136 pi, and then I'm going to add the base. And so it should make sense to you that you would just add the circle. The lateral area doesn't include the circle on the bottom. So I add the circle, which is just doing 136 plus 64, which is 200 pi exactly. This would be in inches squared because it's an area. This is in inches squared because it's an area. All the areas are square units. The volume is going to be cubic units. The volume formula is 1/3 area of the base times height. And that's the only time we use that 15. That capital H only appears in the volume formula. So I do 1/3 area of the base, capital B, times height. And then again, I put that in my calculator, 1/3 of 64 times 15. All the circular stuff has pi's in the answer. Cylinders, cones, spheres, you're going to have pi's in all of those. So when you're done with your test, you can just look through all the cone and cylinder and sphere stuff. All the round stuff has pi's in them. All right. You are going to try this bottom one on your own. Okay? So try to be ahead of me here. The first thing I'm going to do is write the P, the B, the L, and the H. And you could even throw the R in there too. Why don't you try to find all those things, write them down, and we'll see if we get those right, and then we'll do the rest. Well, people are working on 2. Does anybody have questions on number 1 that I did? Okay. Yeah.
Wait, on the actual test, a lot of these are formula sheet, right?
You bet.
And it's gonna have like, it has lateral area and
It's,
all that.
do you have one of these?
Yeah.
That's what it is. So the formula sheet won't explain what P and B and H stand for. So that's your responsibility, but you'll have those formulas.
What's their test?
It's on Tuesday. I'm only laughing because I always have the same answer for you. Check the calendar. So I'm going to start doing some of this stuff. You actually have the L and the H, and you might think, okay, well, I have everything I need because I need the L and the H in the formula, but you can't find the P and the B without the radius. So you draw this here and create a right angle, and then you do Pythagorean theorem. And for Pythagorean theorem, you got to make sure that you know that, you know, on the first one, that's the A and the B. So in the first one, I would have done 8 squared plus 15 squared, and then did the square root and got 17. But on this one, the 25 is the C, so it would have been more like 25 squared minus 24 squared. We've certainly been doing a lot of Pythagorean theorem this year. So, do you need to memorize the triples? No. But people who just know it's 7, not only will it make it faster, but if you know it's 7 and you're like, I'm 90% sure it's 7, and then you do Pythagorean theorem and then you get 7, then you're could be 100% sure. You could say, I'm pretty sure it's 7. I'm gonna do the Pythagorean theorem, and when I get 7, then I can feel really good about this. Perimeter is the circumference of the circle. So you double that radius and multiply times pi, 14 pi. For the area of the base, you're doing pi r squared, that's 49 pi. Those numbers would only be the same if the radius was 2. So if they're the same, I would be suspicious. The only number that would have them be the same would be the number 2. And they're really never the same because this is in inches. It's measuring around this as a linear measure. And this one is in inches squared, which is amount of space inside the circle. So they're actually never the same number. But if you're every single problem, you're getting these two to look the same, that is probably not going to be right. Okay. So then for the lateral area, you're putting in the perimeter of the base times the slant height. This is the same plus the 1 base. Volume is base times height. When you take the test, if you don't want to write those, you just want to go for it on the calculator, you can. I just don't think that's wise. I think it's better to write down what you're about to do and then do it so that if there is a mistake, I'll know what it is. If your quizzes and tests just have wrong answers and no work and no explanation of how you got those wrong answers, you won't get, many points, if any. But if you have what you're doing down and I can see, you write, instead of 25, you wrote 24, okay? It's an understandable mistake. It's not a good thing to do, but at least I'll know what it is. If you just have answers that are wrong, it's really hard to give people partial credit. So the pi's are obviously extremely important. The labels, I'm not too picky about because, if you are one day in a job where you're measuring things, I hardly doubt you're going to be a carpenter and mix up inches and feet or something like that. But it's good to get used to having the right labels. And like I said, areas are always squared. Volumes are always cubed.